particle moves along the x-axis so that its velocity v at any time t for 0 is less than or equal to t and t is less than or equal to 16 is given by v of t equals e to the 2 times sine t power minus 1. At time t equals 0, the particle is at the origin. So, letter A, it acts on the axis provided. Sketch the graph of v of t for 0 less than or equal to t less than or equal to 16. So for this question, this would be a calculator question, and you would graph the function of e to the power of 2 times sine t minus 1. You need to make sure that you have 3 waves. With those 3 waves, you need to make sure that you have a relative min and max value on the 3 waves, and the graph has to start at the origin. Letter B. So letter B asks, during what intervals of time is the particle moving to the left? Give a reason for your answer. So we know that when v of t equals 0, the particle moves to the left. So we look at the graph we created for letter A, and in your calculator, you can press calculate and then 0. You find the zeros on your graph, and then you'll be given time intervals. You can find the time intervals on your graph. The first pair would be pi, 2 pi, union 3 pi, 4 pi, union 5 pi, 16. And these will be the values. This would be the interval that the particle is moving left, since v of t is less than 0, which tells you that e to the power of 2 times sine t is less than 1. Letter C. C asks, find the total distance traveled by the particle from t equals 0 to t equals 4. So the total distance, for sure, you know that you have to take the absolute value, since distance cannot be negative. So you would have the integral of 0 to 4, the absolute value of velocity d of t. And you can simply plug this into your calculator by pressing math 9, and you plug in the function. To insert the absolute value bars, you would put your cursor into the function, press math, and next to math there will be number, and you press 1. Once you plug this function into your calculator, you'll get 10.542. Letter D. Letter D asks, is there any time t where 0 is less than t and t is less than or equal to 16 at which the particle returns to the origin? Justify your answer. So the graph of the integral, we graph the integral of 0 to 16 with the function inside of it into our calculator, and we have to make sure that there is no time which the integral is equal to 0. So once you graph this in a calculator, you will get no function. So there's no time at which the integral of 0 to 6 v t dt is less than or equal to 0. So from this we know that the particle will not return to the origin, because for all values of t is greater than 0. Question number 4. The graph is a differentiable function f on the closed interval -3 to 15 is shown in the figure above. The graph of f has a horizontal tangent at x equals 6. Let g of x equals 5 plus the integral of 6 to x f of t dt for -3 less than or equal to x and x less than or equal to 15. So letter A asks us to find g of 6, g prime of 6, and g double prime of 6. So to begin with, we'll find g of 6. So we already know that g equals f. So to find g of 6, we would put the original function. We'll put 5 plus 6, the integral of 6 to 6 of f of 6 dt. And since 6 to 6 is not going nowhere, the answer would just be 5. Yeah, the answer would just be 5. So g prime of x, we know that g prime is equal to f. So we could look directly at the graph and find the height of 6, the height at 6. So f g prime of 6, which equals to f of 6, will be 3. So g double prime of 6 is equal to f prime of 6. So since this is a graph of f, we need to look at the slope of it when it's at 6. Since g double prime is the derivative, so the slope at 6 is 0. Letter B asks, on what interval is g decreasing? Justify your answer. Okay, so since this is a graph of the derivative, we need to look at the values below the x-axis to determine if it is decreasing, which you can see the values are -3, 0, union 12, 15. And this is because g prime of x equals f of x, which is less than 0. Letter C asks, on what interval is the graph of g concave down? Justify your answer. So g is basically position, in which f can be basically velocity. So here, since we're trying to find concavity, we are finding acceleration, or in other words, f prime, which determines concavity altogether. So since g double prime of x equals f prime of x, which is less than 0, we can see that the interval which the graph is concave down is from 6 to 15.
Ship A is traveling due west towards Lighthouse Rock at a speed of 15 kilometers per hour. So right away, I'm going to write down that dx over dt is -15 kilometers per hour. Now at the same time, ship B is traveling northway from Lighthouse Rock at a speed of 10 kilometers per hour. And so they would write down, as the y values are getting more positive, dy over dt is equal to positive 10 kilometers per hour. And we let x be the distance between ship A and Lighthouse Rock at time t, and y be the distance between ship B and Lighthouse Rock at time t, as shown in the figure above. First, find the distance in kilometers between ship A and ship B when x is 4 and y is 3 kilometers. Well, here we have a simple Pythagorean triple. When x is 4, y is 3, then s, the distance between two ships, will be 5 seconds.